So this problem here, problem 1.9, is an example of the hypergeometric distribution. So there are basically 100 good fish in the lake. There are 100 fish that are tagged. So these are the good ones, and then all the other ones are the bad ones. And so the question looks for, so x is going to be hypergeometric. So let x is the number of fish caught that are tagged. Then x will be hypergeometric. There are n fish in the lake. There are 100 good fish in the lake. And we are pulling out 100 extra fish. So there are 100 fish that are tagged, and we're pulling out a sample of size 100. So the question is asking, what's the probability that x equals 5? Okay, well, there are 100 good fish in the lake. There are n minus 100 bad fish in the lake. And there are n total fish in the lake. We are pulling out 100 fish. 5 of these 100 should be tagged, which means 95 would not be tagged. And so basically that is the answer. That is, we could express this in terms of factorials if we wished. So that would be 100 factorial over 5 factorial, 95 factorial. The next term would be n minus 100 factorial over 95 factorial, n minus 195 factorial. And then the last one would be, because I'm dividing, the n factorial goes in the bottom, and then we'd have 100 factorial, n minus 100 factorial on top. So we could do that, but there's really no great simplification, and it's certainly correct to just leave it like this. The problem here just is a matter of identification. So the second part of the problem is nothing that I would expect in this class, but just an FYI, that this type of problem would be used in statistics to estimate the number of fish in the lake. So counting the number of fish in the lake is probably not realistic, but you can tag 100 fish and then catch 100 more and see how many of those are tagged. And the value of n that would make this very complicated fraction as large as possible would be our best estimate for the number of fish in the lake. And the procedure for finding the best value of n is a little bit complicated, so I'm not going to worry about that for this course, but I just wanted to point that out, that this is indeed a real-life application of the hypergeometric distribution.